This is notes on 5.5. So the main topic is average value, but we're also going to talk about odd and even functions and how that helps you integrate. So what is an odd function? So an odd function is one that is symmetric about the origin. So if you have a point here, let me do a color. If you go across the origin, you'll have a point opposite of it. So point here, you go across the origin, you have a point opposite. We'll do this one. You're here, you go across the origin, you have the point directly opposite. You have a point here, you go across the origin, you have a point directly opposite. So every point through the origin, you have a point the same distance opposite the origin. That would be an odd function. So in an even function, it's symmetric about the y-axis. So if I go across the y-axis, I'll find a symmetrical point. So if I go the same distance across, bam. Same distance across, bam. Same distance across, bam. So any point I pick, if I go across the y-axis, there's an equivalent point. So all these would be example of even functions. All right. So how do you test, excuse me, if you have an odd or even function? Well, take a look. If I pick any point and I plug in x, let me zoom in here. So if I plug in a value of x, I will get a value of y here. Now, if I go minus x, your y value should be opposite. That should be minus y. So x, you get a y value. The opposite x, you should get the opposite y value. So the y values are going to be opposites of each other with opposite x's. That's what this is saying. If I have an x and a minus x, they're going to be opposite of each other. Now you could put the minus here instead, the same thing. But so first you plug in x, then you plug in minus x, and you compare your answers. If they are opposites of each other, you know you have odd. For even, you plug in x and you plug in minus x. But if you plug in x and minus x, the y values will be the same at both those places. Okay? So whether you plug in x, excuse me, didn't mean to do that. When you plug in x or minus x, you're going to get the same value on both those. That's how you test for even. So let's do this. F of x, that's easy. X plus sine x. F of minus x, that's going to be minus x plus sine of minus x. Now, here's a question. What is the sine of minus x in terms of sine? Because I want to compare these two answers. If they are opposites, they're odd. If they're exactly the same, then it's even. Well, unit circle time. So if I pick an angle, x, what does the sine of minus x look like? Well, minus x is going to be down here. That's minus x, if that's plus x as far as an angle is concerned. Here, you get y. But if you use minus x, you can get minus y. So if I use a negative angle, my sine switches signs. So what that's saying, if I make it a positive x, it's going to come out opposite because these have opposite signs. So if I switch from here to a negative, my y is going to be negative. If I switch from a negative to a positive, it go from negative to positive. So that's why if I change your angle with the opposite, you're going to get the opposite. So let's compare the two. Our final conclusion. That can be factored to minus 1 x plus sine x. And they are opposites. That is, these are the same, but a negative. They're opposites. Therefore, this is an odd function. Okay? Here, let's try plugging in minus x. I get minus x squared minus absolute value of minus x. That's x squared plus, or excuse me, the absolute value gets rid of any minuses, so it just becomes x. If you look at that and you look at that, they're exactly the same. Therefore, this is an even function. So that's kind of a quick rundown on how you would test for odd and even. Just a reminder, to find out odd, you plug in a minus x in for all the x's, and if your answers are exactly opposite of each other, then it's odd. Then, for this one, we plugged in a minus x for all the x's. If your answer is the same as your original, then it's even. So that's the testing of odd and even. But what does that have to do with anything? This is pretty easy. You probably don't even have to memorize this because it makes so much sense. So if f is an even function and you integrate from minus a to a, here's an example. This is an even function. I integrate from minus a to a. Isn't it obvious that this, let me change colors here, this net area and this net area would be exactly the same? So the theorem says I can go from 0 to a instead, get this net area, and double it. And it's the same as the whole thing. So very logical. So this enables you to do a lot easier fundamental theorem calculus applications, and life becomes easier. Now, if it's odd, so here's an example of an odd function. And if you integrate from negative a to a, it should be obvious that this net area and this net area, they're going to cancel each other out. So you're just going to get 0. So when you integrate an odd function to even left and right point, those areas will cancel out for a net area of 0. So that's what that theorem says. All right, so we have a couple examples to do. Now, here's the problem. This is neither odd nor even, but that is even, and this is odd. You can double check that. We can rewrite this as two separate integrals, because that's one of the rules of integration that we learned. Well, according to our properties, this is an odd function. Therefore, that is going to have a net area of 0. This is an even function, so we can rewrite that and double the answer from 0 to 2 of x to the 4th. And then we take the antiderivative, 2 is a constant, we add 1 to the exponent and divide by that from 0 to 2. And that's why it's easier. You get a 0 there, plug in 0, you just get 0. So our answer is going to be 2 times 2 to the 5th power over 5. What is that? 4, 8, 16, 30, 64 over 5 is the answer to that question. Okay? So we use the properties of odd and even to make integration a lot easier. All right? So the cosine function, that's going to be an even function. Sine function, that's going to be odd. So we can break this up into two separate integrals. And we'll do cos x for one, pull a constant 4 out, and do sine x for the other. But since sine is an odd function from negative 2 to 2, the theorem says that's just going to be 0. So we don't need that part. So all we have left is a cosine. And the antiderivative of cosine is the sine. Oh, I didn't do that. One more step. Since the cosine is an even function, I can just do half the integral and double it. My life is going to be so much easier. The antiderivative of cos x is sine x. I'm going to go from 0 to pi over 2, which will be 2 sine pi over 2 minus 2 sine 0, which is 2 minus 0, which is 2. Bam! So I'm taking advantage of my odd and even properties to do integration. All right, average value of a function. Let me kind of explain this. This is a lot easier than it looks. So let me explain. We're calling this function f of x, and we're going from A to B. And imagine this is a swimming pool, an aquarium, and I'm an astronaut, and I'm off into space, and because of no gravity, the top of my aquarium is not flat, it is curved. Okay? I have fishies in this aquarium. Whoops, not that fishy. Here he goes. Yeah, see the fishy? I'll give him a black eye. I have a fishy in this aquarium swimming around. And then if I want the area of the water in this tank, I know it's volume, but let's assume the tank is 1 inch deep. So we can get the area just by or the volume is the area of the front times 1, which is hopefully you get the idea. So if I wanted the amount of water here, I would integrate f of x from A to B. What does that equal? The net area. So that's the area of this water right here, right? Now, when I land my spacecraft, gravity is going to flatten that water out. So all that water that was kind of wavy is now going to level out into a flat level, okay? So all my water is going to fill in and flatten out like that. And the height of the water is going to be somewhere between the high point and the low point, which it is. It's somewhere in between. So we actually have a name for this. This is the average value. So that's I'm going to abbreviate it AV. That's the average value. Now, the length of this base here is B minus A. So the same thing, these are the same points. The distance between those points is B minus A. Here is the part that is the big takeaway. What's the area here? The area here is base times height. What's the base of this rectangle? B minus A. What's the height? The height is the average value, because that's what we called the height here, the average value. So here's the area of the orange. Here's the area of my blue. They got to be the same because it's the same water. This is the water in the tank in space. When I land, it flattens out, but this area has to be the same as that area. So I'm going to write that down. First, I'm going to put the area of the orange, B minus A times the average value equals the integral from A to B of f of x dx. So if I want the average value of my function, I divide both sides by B minus A. And so now I have the average value of the function is the integral divided by the width. There's my formula for average value, but that's this formula right here, which is the same as this one where the B minus A is out in front. Okay, so that's how you find the average value. Now here's another way of thinking about it. When someone says find the average or the mean, you would add up all your numbers and divide by the number of numbers, right? Well, that's kind of what we're doing here. When you integrate, remember this is like adding. You're summing up all your f's and dividing by how many f's you had. Kind of, that's the process. How do you find the average? There's too many numbers here to add up and then to divide. So using calculus, when you integrate, in a sense, you're adding up all these numbers, y values, and then when you divide by b minus a, you're dividing by the number of points. It gives you the average of all the numbers. So another way of looking, you add them all up and divide by all the numbers. So that's how you find the average value of a function. Now there's a theorem that's related to this average value. So if you have a continuous function on an interval, just like we had above, there exists a point C inside that interval such that the function at that point C is the average value. What does that mean? Let me go back to this picture. Okay. We found the average value right here. So this is the average value. What this theorem is saying, that's the average value. So over here, it's the average value. What this is saying is that there's going to be a C between A and B where the function equals the average value. Well, I have found it. It's right there because this is the average value, this is the function, and they do equal, and the point where they equal we call point C. So that is my C, which is between A and B. So it's saying there's going to be a C between A and B where the Y value there is going to equal the average value. But what point is that? That's f of C. F of C equals the average value. So this theorem says if you have a continuous function, then there's going to be a point x value between A and B where your function will equal the average value. All right, so here's an example. Find the point or points on the interval from 0 to 1 where this integral equals its average value. Well, what's the average value of f of x? The average value of f of x will be the integral of f of x from 0 to 1 divided by 1 minus 0. That's just this formula to find the average value. I'm going to distribute this to get my f of x to be 2x minus 2x squared, and I will plug it into this formula. So the average value will be the integral from 0 to 1 of 2x minus 2x squared, all divided by 1, because that's just 1, which is 2x squared over 2 minus 2x cubed over 3 from 0 to 1. I plug in 1 on top. I plug in 1 again for the second part of that. Then I plug in 0. But when you plug in 0, that's just 0. So it's minus 0. So here's my answer. That's going to be 1 minus 2/3, which is 1/3. That's my average value of this function. But find the points on the interval, actually it should be in this interval, where the function equals the average value. So we want to know when this equals 1/3. So let's do that. They want to know when your function equals 1/3. My function is 2x minus 2x squared. Well, I don't like the fraction. I'm going to multiply everything by 3 on both sides to make my life better. I'm going to get 6x minus 6x squared equals 1. Or I'm going to add everything. Okay, I'm going to add 6x squared to both sides to get that. Subtract 6x from both sides. And that becomes my equation. I'm going to factor that because it's equal to 0. Should I do 6 and 1 or 3 and 2? I don't think either of these is going to work. So I actually might have to use a quadratic equation on this because to me, it looks like it's not going to factor right. If I do 6 and 1, I'm going to end up with a 5 in the middle or a 7. And if I use 2 and 3, I'm going to end up with a 5 or a 1 in the middle. So neither of those are working. So I'm going to have to use the quadratic formula, and I'm going to have to cheat and tell you what this is. So using the quadratic formula, you're going to get an x about 0.211 and 0.789. And since both of these are between 0 and 1, because that's our interval, we are good. These are the two values of x where that will be true. All right? So we need to be careful because every year people get confused between average value and average rate of change. And I think the reason that happens is because both these contain average and they don't distinguish what it means. So average value versus average rate of change. Rate of change is you're comparing two things, the rate of something. The top is delta y and the bottom is delta x in this case. So it's like the slope of a secant line, but it's rate of change of how fast y is changing compared to x. Where average value, you got to think about it more of like when you add up a bunch of things, divide by how many terms. So think about the integration as adding all the f's and dividing by how many, by all of the f's, by the number of them. So make sure you don't get confused between these two. Very important, or you're going to miss really easy points. And so the average value, you integrate and divide by the width. For the average rate of change, it's f of b minus f of a over b minus a. Like this is the 2014 FRQ. If you took this test in 2014, this is the question you would have had. But question number 1, and it has all these concepts in there. So part A, find the average rate of change of A over the interval from 0 to 30. So key, rate of change. So that's going to be f of b minus f of a over b minus a. I'm not going to calculate this out because you need a calculator, but I'm going to show you how you would set it up. It would be a at 30 minus a at 0 over 30 minus 0. Now you could put this in your calculator. They give you a. I'm not going to do that, but just to point out, that's how you would do that problem. Then B, find a prime at 15, or the derivative. Now, you could do this on your calculator, but you guys should be able to do this without a calculator. So first, I'm going to find the derivative of A. The 6.687 is a constant. And then, this is like e to the x. It's exponential, but the base is not e. So I am my own grandpa. So it's going to be e to the x still, but just t. But you also need ln of the base. So that's going to be the derivative of a. But if you want it at 15, you would get a number. And I think I'm going to get this answer for you here. Do I have it? I don't have it. Maybe I do. All right, it's okay. I actually can get it pretty quickly. Let me pop it up here. Sorry that I'm making this video last longer. This is number 1. I'll get the answer for you. All right, so the answer came out to be negative 0.164. And I knew it was going to be negative. You know how? The ln of anything smaller than 1 is negative. So I knew it was going to be negative. So using correct units, interpret the meaning of this value in the context of the problem. First, what is A? A represents what? The amount of grass clippings remaining in the bin is A. So A is the amount of grass clippings. Now this is a derivative. What did you learn if the derivative was negative? That your function's decreasing. So now we know A is decreasing, but A is the amount of grass clippings. So you would say the amount of grass clippings in the bin is decreasing at the rate of 0.164, and now you need your units. A prime is dA dt. A is measured in, it tells us there somewhere, pounds. T is measured in days, I believe. Days. So it would be the amount of grass clippings in the bin is decreasing at the rate of 0.164 pounds per day when T is 15, or when time is 15 days. So that's the answer for part B. Let's do part C. Find the time T for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin. So the next thing is the average amount of grass clippings. How do we find that? Well, we just learned the formula. The average amount of grass clippings, I'll call it average value. We're going to call it the integral. I'm not going to call it. It is the integral from 0 to 30 of A of t dt divided by 30 minus 0. Now, this is a calculator problem. If you were to work this out, you would get a number. I don't know. You get some number. Okay, that's the average amount. But what do they want you to do with that? Find the time for which the amount of grass clippings is equal to the average amount. Well, how many grass clippings do we have? This is the amount of grass clippings. So we want the average value to equal the actual amount, which is 6.687 times 0.931 t. Now, a couple ways you could do this. You could solve for t using algebra. So take this value that you find, divide by that, and then you can ln both sides, p in front of the log. Well, you can manipulate that. Or another way, you find this answer, graph it on your calculator, you graph this function on your calculator, and find where they intersect. But the main point I wanted to get across is that you know how to find the average value. And you know the difference between average value and average rate of change. So that's it for this lesson. Bye-bye.